Hello, welcome to my channel. Our today's video is about profit maximization. Question number 33, functions of several variables. A small firm manufactures two goods X and Y, and market price of these goods is unaffected by the level of the firm's production. If the firm's cost function is C of xy equals 2x square plus xy plus 2y square, and the market price of x is $12 per unit and the market price of y is $18 per unit, determine the number of units of each so that the firm's profit is maximum. Now here we have to maximize the profit function. Cost function is given. We will write the total revenue function, and after that profit function. Now here cost function is total cost equals 2x square plus xy plus 2y square, and total revenue function is $12 times x plus 18 times y, because it costs the firm $12 each unit of x and $18 for each unit of y. Therefore, profit function is pi of xy equals total revenue minus total cost. Total revenue function is 12x plus 18y minus total cost 2x square plus xy plus 2y square. Now removing the brackets, 12x plus 18y minus 2x square minus xy minus 2y square. Now we will find partial derivatives. Finding partial derivatives. Pi x, pi xx, pi xy, and pi y, pi yy. Therefore, partial pi by partial x equals 12 minus 4x minus y. Then second order partial derivative with respect to x will be minus 4, and second order partial derivative xy will be minus 1. I have partially differentiated pi x with respect to y to obtain pi xy. Now partially differentiating with respect to y, we have 18 minus x minus 4y. Again partially differentiating with respect to y, we have minus 4. Now for critical points, put partial derivative with respect to x and y equal to 0. For critical points, put partial pi by partial x equal to 0 and partial pi by partial y equal to 0. Therefore, partial pi by partial x equal to 0 implies that (12 minus 4x minus y), 12 minus 4x minus y equals 0. This is our first equation. Also, partial pi by partial y equals 0 implies that (18 minus x minus 4y) equal to 0. This is our second equation. Now we will solve 1 and 2 simultaneously to get values of x and y. Now we will remove y. For that we will multiply first equation by 4 and subtract equation 2 from it. So 4 times equation 1 minus equation 2 implies 4 times equation 1. 4 times 12 is 48. 4 times 4 16x minus 4y equals 0. Second equation as it is, 18 minus x minus 4y equal 0. Now subtracting, minus 4y plus 4y cancelled, 48 minus 18, 30 is left, minus 16 plus 1 is minus 15x equals 0. This implies that 15x equals 30. 15 times 2 is 30. This implies that x equals 2. Now to find y, put x equal to 2 in equation 1. Put in 1. 1 implies 12 minus 4x minus 4 times 2 minus y equals 0. Now 12 minus 8 minus y equals 0. This implies that 4 minus y equals 0. This implies that y equals 4. Therefore, the critical values are x equals 2 and y equals 4. These are the critical values. Now we use Hessian to check whether these are points of maxima or minima. The Hessian is h equals second order partial derivative with respect to x multiplied by second order partial derivative with respect to y minus second order partial derivative xy whole square. Putting the values, pi xx is minus 4, pi yy is also minus 4, pi xy is -1. H equals 16 minus 1. Minus 1 square is 1. This is equal to 15, which is positive. Also, second order partial derivative with respect to x is -4, which is negative. Therefore, x equal to 2 and y equal to 4 are points of maxima. That is, these quantities will give maximum profit. Now, maximum profit is pi max at 2, 4 equals now profit function is 12x plus 18y. 12x, x is 2 plus 18y, y is 4 minus 2x square minus xy minus 2x square mean 2 square minus xy 2 times 4 minus 2y square minus 2 times 4 square. Now simplifying, we will get maximum profit. Twelve times 2 24 plus 18 times 4 is 72 minus 2 square is 4, 4 times 2 is 8 minus 2 times 4 is 8 minus 2 times 4 square, that is 2 times 16 is 32. This implies that maximum profit equals 2 plus 4 6, 7 plus 2 9 minus 8 plus 8 16 plus 2 18, 8 1 carry, 3 plus 1 4. So 96 minus 48, $48 is the maximum profit. Thanks for watching my video. Allah Hafiz.